Hello everyone. In this video, I'd like to briefly demonstrate the project Retrieval-Augmented Generation system with local LLM. All the codes and the reports could find on my GitHub repo here. It introduces the features of my project, the pre-request to get started, and how to run the application. First, let me introduce the overall structure of my code. The code consists of several parts. The first one is configuration parts. In this part, I set the environmental configuration, the max number of the max number of Olama could run in parallel, and the max models could load it, and the max context length, the temperature, the token limit, and the system prompt. And what is the embedding model, the embodied model name, the base LLM model name, and the file types the rack system supported, and so on, and other informations. And in the utils part, I implemented two methods. First one handles the file uploads and return a temporary directory path. And next one it calculates MD5 hash for the uploaded file, which is used for handle multiple file uploading. In the models part, I implement two methods. First one is used to initialize rack modes, and the other one is used to initialize the non-rack mode. So for initialize the rack modes, I use the llama index package, and I define the embed model for embed models, and here is read the document and get the vector store index from the documents, and return the chat engine. And for the non-rack mode, I simply using the Olama directly. This part is user interface. I set up the sidebars, controls, and return configurations. There shows parameters, shows max links, show other buttons for user interaction with the model, and I define method to create new conversation, to clear the history, and display chat. The rack module.py file defines the logic of handle rack mode. This method defines the logic to generate the rack response. Here, I record the start time, start CPU usage percentage, and start memory usage percent, which are used to monitor the resource usage and time consumption to compare with non-rack model. And this part, non-rack module.py, implements the non-rack mode logic. This method generates non-rack response. It also records the resource usage and the time consumption. Next part is app.py. This is the user entry to start the application. So let's start the application. Just type streamlit run app.py. there. Okay, here's the overall user interface. This button let user switch from RAG mode to non-RAG mode. And here's the parameters you can change: max contact length, temperature. And here's two buttons. You can create new chat or clear the history. So in the RAG mode, you can also click this button to upload files. So first, let's chat with the non-RAG mode. Here shows the model is running. You can also click stop. Okay, so in the here is the response. In the left side bar shows the response time, CPU usage, and the memory usage. Let's switch to RAG mode. You can upload files from the through this button or delete files by click this and just create a new chat. And let me. So if you don't upload, if you have not uploaded files in the RAG mode and try to chat with the bot, it will remind you, please upload files first or switch to non-RAG mode. So let's upload file first. So the file I chose is basically a short report, introduce the history of computers and its generation. So let me ask a question. What is the author of the report I uploaded? And you can see it consumed more times to get the response. Let me check if this answer is right. Obviously, it's the RAG system get the correct answer. Okay, so here is all about the RAG system. And yeah, that's the basic implementation and integration of RAG system. And next, I do some comparative analysis and reflection. I prepare 10 questions. The first 6 questions is the first 6 questions are from the report. From this report, history of computer generation. And next 4 questions is some general question about computer science. And I test them in standalone Llama 2 with RAG system, the Llama 2 with RAG system, and Llama 3, standalone Llama 3, and Llama 3 with RAG system. And you can see I saved all the chat history. You can see it looks like here. You can see all the details on my GitHub repo. Let us see the QA result. You see RAG system enhance the accuracy, and here are some analysis from relevance, accuracy, and context awareness. You can see the detailed analysis of my report, and some performance analysis, which includes response time, CPU usage, and memory usage. and a reflection. And I also document implementation challenges and how I solve it. And last part is user experience and functionality. Okay, so that's all for my project. Thanks for watching.